Okay, welcome everyone. Welcome everyone. We're here for this webinar. The webinar is called Sustainable Solutions for the Reduction in Water Losses, Reduction of Non-Rainwater, and Service Level Improvements in Water Distribution Networks in Cities of India. And the webinar is kindly given by Vijay Kumar. All right, so what's going to happen, Vijay is going to do his webinar. It's going to take approximately 40 minutes. And when he's done, we're going to go to 10 to 15 minutes of questions and answers. I'm going to put it on the chat now, but please be welcome to put your questions on the chat, and then I will read them aloud. And if there's time and somebody wants to do the question itself on live, is also welcome too. So without any delays, I'm just going to give the microphone to Vijay. Vijay is going to introduce himself and going to start the webinar. Thank you very much. And I'm going to mute everyone. Sorry, guys. So there's no background noises or things like that. Thank you.
Yeah, thank you so much. So, ladies and gentlemen, good morning and good afternoon and good evening. It is with great pleasure that I am welcoming you to this webinar regarding sustainable solution for reduction in water losses and reduction in non-revenue water and service level improvement in water distribution networks in cities across India. So myself, RL Vijay Kumar, and I am presently associated with the Sciences Tech Limited, and I am also one of the management committee member of Water Loss Specialist Group. So I am expertise in water loss reduction and preparation of DPR management consultancy to the governments and hydraulic modeling. So in this webinar, what are the things we are going to see? The challenges in Indian water distribution network, then the challenges in survey work and mitigating solution, and tips for modeling and water distribution design, and leak detection goes on the practical solution which we have adopted. The tips to monitoring the water loss reduction activities, a proposed strategy for implementing of effective NRW reduction activities, and the change management. See, the challenges mentioned in this webinar is not unique across the cities of India. Each city is having their own challenges. So considering the time limit, I have collaged the crucial challenges based on my personal experience. So the major challenges of water supply schemes in India are high NRW level and lacking NRW management strategy and team, and insufficient funding, then improper design and implementation of water loss reduction activities, then options of the monitoring system, and lacking asset management and database, and lacking revenue mechanism, intermittent supply towards service level, and illegal connections. So these are the major challenges in India. Conducting a comprehensive survey is a crucial activity as the entire design and implementation process relies on accurate survey data. So it is essential to keep in mind that the GIGO, the garbage in is a garbage out. So what are the drawbacks we have observed during the survey? The surveyors may lack of sufficient understanding of the core purpose of the survey and specific data that needs to be captured. Then the important details such as number of flats and storage capacity of the particular property, then the pipeline alignment, whether the pipeline is in the right side or left side of the road, and the economic condition of the location, then alternate water supply, etc. Then the property, sometimes the people will do the consumer survey based on the manual writing in the paper, and they will submit. So what will happen? This will manual process make it challenge to accurately assign the consumers to the specific DMA boundaries. Then improper address details and lack of consumer support, and sometimes inability to access the closed doors. So the surveys may or may not be revisit the property again so that those are the drawbacks over there. Then there is a size and material of pipeline may not be accurately confirmed during the survey by sufficient trial pits, and the use of less accurate GPS may compromise the precision and the reliability of location which data which captured during the survey. Also, the challenges may arise in tracing devices like pipe locator, GPR, and accurately capturing data due to the unorganized installation of the other underground utilities in the where the pipelines are laying, and defunct pipelines, and at the presence of the RCC road. So these are the major drawbacks. So what are the, based on our experience, so what are the tips we are actually giving over here? And when I was associated with some project regarding to water loss reduction, so we have used the GS-based tabs to survey the consumer survey. Then observe the detail like alternate water source of the property and number of flats in each property and occupants in the each flats, then socio-economic details. So this is required to form the demographic profile of the particular area, and then storage capacity and the capture vacant land, the commercial or semi-commercial, and if the meter is installed, what is the make of the meter and gauge, and whether it's a tampered or not tampered. And the main thing is house service connection, whether it is in the long side or short side. This is also important whenever we are going for the water loss reduction activities. Then during the survey, what we have done, we have identified the illegal connections also. So either if we have a team, we had a team, so that we have did the open sounding method. So this is also one of the acoustic based method. It will work in the both way. You can identify the illegal connection, at the same time we can identify the leakage in the ferrules and the house series connection. Other, at least the person should go to check their some, whether they're having one or two inlets, and whether the meter bypassing are there. So these are the tips. Then inform to community before you commence of work by awareness program or notices. That also we have did during our survey. So asset survey. So whenever you are doing the asset survey of the existing network, so we have to capture the administrative boundaries such as ward boundary and the constituency boundaries and the water supply zones. See, water supply zones, it is not a single boundary. In Indian cities, even a small area also, there may be the pocket wise flow measurement supply. So where, at which time, where and all they are giving the flow, so that flow boundary also to be captured. Then observe the details like pipeline alignment, whether the left side or upside, the depth of the pipeline and the fittings and materials and size, all those things we have to observe during the survey. Then identify the position of the valves. If it is operating valves, then we have to collect the operating schedule of the valve, at what time it will open, what time it will close. If it is a throttling valve, then we have to understand what is the position of the opening of the throttling valve, whether it open one round or two round. And at the same time, whether the valve is in closed, permanently closed condition, whether is a boundary valve, so etc. we have to capture. Then employ multiple methodologies during the survey, including visual inspection, pipe locator you can use, and GPR you can use, box locator for identify the buried walls, and trial pits for analysis of the old map, then engagement with local communities and technical assumptions. So all those things actually we have to capture during our the survey. Then you have to capture the nearby underground utilities as well. Then pressure mapping. So conduct the pressure mapping to understand the pressure variation across the water supply area, both at the consumer end and within the network. So in the consumer end, how we have calculated the pressure mapping, we have used the digital pressure, calibrated digital pressure gauge, and randomly, particular street in the starting and middle and end, we have captured the pressure at the consumer tapping. At the same time, we have installed some temporary pressure loggers in the network, so that it will give the idea about the area. So the pressure variation among the area. Then dig multiple trial pits. Strategically, you have to plan where I have to put the trial pits, because in the road everywhere we cannot put the trial pits. So you have to strategically plan that and confirm the pipeline by making the sufficient trial pits. Then double end charging and tube well, it is very important. The double end charging is nothing but, despite the replacement of the old pipeline, the water supply remains there in the both the pipelines, due to delinking failures. At the same time, tube well in India, sometimes during scarcity and to manage the demand, so the tube wells are directly connected to the network. In between there is a NR will be there, the non-return valve. So like cases I have faced many times, sometimes the non-revenue valves get failed. So what will happen when during the supply time, the water will charge the tube well. See, none of the leakage detection, no one can identify whether if the water is going in the tube well. So that is also the big classes. This type of cases I have identified a lot. So that is why during the survey you have to map the tube well, if it is tube well which is directly connected to the network. Then pipeline condition analysis also you have to do by trial pit, and you can insert the leveling camera inside the pipeline. This photograph shows the leveling camera which we have inserted. See the incrustations and blackage inside the pipeline. So these are the pipeline we can go for the replacement. So it will give some idea about the entire existing network. Then I just want to give some tips regarding to the modeling. Whenever we are doing the modeling in the intermittent water supply system, and we are going to implement the water loss reduction based on that modeling, then these are the points we have to consider, and we have did in some of the project. So first of all, consider the surveyed population for base year instead of the projected population. So generally what will happen, client won't give put it in the scope that you just project the population based on the statistical methods. But what we have did the consider the surveyed population. Why? because we can calculate the accurate population density along the area. At the same time, we can fine tuning by analyzing the error between projected population and the survey population can be done. For example, if 2023 you have calculated the population based on some statistical method, at the same time the actual survey is there. So if you compare the value, it will give the error analysis. So based on that, you can tune up your future population which you are going to design, and adopt the peak factor based on the actual supply hours. But see, if you adopt a peak factor based on the actual supply hour, but as per the Indian scenario, this can lead to unnecessary capital expenditure, because we know we are having the supply of 4 hours, 5 hours. So if you adopt the peak factor based on that, then the peak factor may be 6 or 7 like that. So it will increase your capital expenditure. So in general, we always do the consider the peak factor of the 3. So in that case, at least after the implementation, we have to you will be to ensure that to extend the supply hours, because we are designing for the 3 peak factor and we are giving supply for the 2. So definitely the network won't work efficiently. So we have to increase the supply. Then allocate water demand based on the actual population density rather than relying solely on automatic allocation. So whenever we are doing the modeling, the Thyssen polygon will make if we chosen the area basis, but at the same time we have to consider the density of the population also with respect to area. So if we have adopted for the automatic calculation, then again you have to reach it with the ground reality, so whether proper demand is allocated in the particular area or not. At the same time, whenever we are doing allocate demand, you should consider for the demographic profile also based on the usage. At the same time, we must exclude the uninhabited areas like park, the roads and vacant land. So that and all should be removed in the GS platform. Then you allocate the demand over there, so that at least we can have a good design based on the ground reality. Then it is very much important. So in general, we are using the demand-driven analysis. But if you are going to improve then water loss reduction activities, so it should be the area modeling should be simulated with the pressure-driven analysis, because the pressure-driven analysis gives a satisfactory result in terms of variation in nodal outflow with respect to the residual pressure variation, right? At the same time, you have to analyze the impact of household storage and the service connection pipe during design, which can help to capture the ground reality in terms of actual withdrawal of water from the system. So these are both things you have to do in the initial stage of design. That is why I have said, whenever we are doing the survey, we have to calculate the house risk connection condition, house risk connection of the property, at the same time the storage capacity also, so which will give the impact in during your design, especially in the intermittent water supply. Then whenever you are doing the design, what we did, we have do the DMA itself. Now we will form the proposed DMA. At the same time, step design is very much important, because step test is the only thing we can use to find out the leak prone area during. It's a continuous process whenever we are in the monitoring stage or leak detection time. So the step design is very much important. And in our one of the project, we have done the calibration of network after the DMA formation. So we have calculated the C value of the retained pipeline, existing pipeline, old age pipeline. We have calculated from the ground, and we have used that value during our calibration. After that only we have made it nearby what you call at least 80-85% calibration we have made with respect to theoretical and the ground reality. In sorry. Include pressure reducing valves, flow control valves, and variable frequency drives to optimize pressure management and operating efficiency during the design. So whenever you are doing the basic design, you should include all those things, because normally what is happening, we will do the design, and after that again you have to redo the design whenever we are going to implement the things. But it should go in one slot. Then to accurately depict the system behavior, allocate suitable average zonal pressure and critical pressure point based on the water supply subzone within the DMA. The average zonal pressure and critical pressure point is very much important, because based on that we can monitor the improvement, behavior and the improvement of the system. At the same time, we monitor the issues in the DMA. So that is very much important. So whatever the design we are doing, so we have to consider the number of wherever required. So we have to fix the average zonal pressure and critical pressure point. Then these are the challenges in leak detection which I have faced in the intermittent water supply system. So one is the limited detection time, as everyone knows, due to the shorter time of supply and inefficiency of the acoustic. I have used mostly, acoustic equipment. So inefficiency of the acoustic equipments, during daytime, because of the background noises. There is a low pressure in the network and saturation time. So saturation time, nothing but whenever the pipelines, whenever actually we start the supply into the DMA. So initially in the intermittent supply, what will happen? First, the pipe will get filled. So after that only it will reach somewhat the pressure will improve in the network, then it will go to the consumer end. So this is also one of the reasons. So in a 4-hour supply, so we will get the only very less hours to do the leak reduction in the particular area. So once the acceleration time is reached, at the same time, immediately, very nearly the supply is going, will get close. So that's also a problem we have faced. Then pumps, some area where the low pressures are there, consumer directly connected the pump into the network, so which to suck the water, so which also drastically reduce the system performance and the system pressure. The challenges with the infrastructure is nothing but the high thickness concrete road and tar pavements and RCC roads. So in that, what happens? It will hinder the leak detection using acoustic equipments, because the leak sound dissipates before reach the surface, and also sometimes the repairs also more complex to do that. Then unknown taps along the main and submain create challenges in leak detection, especially using leak noise correlator. In Indian condition, we cannot efficiently use leak noise correlator in a service pipe, because whenever the supply is there, so all the house service connection, the people will draw the water, even the end of the supply also. So if you use the leak noise correlator, so it won't work efficiently in the service pipeline. So now we have used this leak noise correlator in 150 mm and above diameters. So sometimes what happen, there might be the unknown tapping will be there, so it will show us the leak. So again, indirectly, it will help us also to identify the unknown tapping. So using the leak noise, correlator, we have identified a lot of unknown tapping which we have missed out in the survey. So we have used it in either way. Then parking of vehicle along the pipeline, this is also a big hectic here, because in the night time we cannot, approach the people to remove the cars, and they won't support also. These are the big issues. Then there's if compared to acoustic, there's a low frequency of noise. If it is a small leak, then leak noise will be more. If it is a bigger, higher leak, the leak noise will be less. So due to the condition of the surface, there may be leak noise cannot come out and reach out to the surface. Before that, it will get dissipated. So these are just one of the challenge during the leak detections. And contamination, contamination also because leak issues, because see, contamination will happen based on the leakage only. But the thing is, if contamination, the contamination will absorb by the dead end peoples, but we have to trace out which leakage is contributed this contaminations from the house service connection, or it is from the upstream, or it is from the some other pocket. So this is the thing also, the difficulty we have faced during our leak detection. So based on these challenges, we have adopted some practical solution for which we have used while we have done the leak detection. So initially coordinate with the urban local bodies for nighttime supply, and you can extend the supply. So wherever it is not possible about the nighttime supply and extend supply, we have used the tanker method. So we cannot put the water in the entire DMA. Based on our analysis, you have to identify the leak prone area and some small pocket. You can pour the water to the tanker, and with the pressurize, so you can pressurize the system and you can start leak detection by using the tanker method. Then started the leak detection after saturation, that I have already said. So initial stage, the pipe will get filled, so you have to wait up to the improvement of the pressure. If it's not possible, then artificially we have to improve the pressure. Then monitor the real time flow rate. See, whenever if you do monitor the DMA meter while supplying, so initially the supply will get start, then it will go to some flow rate. After the end of the supply, nearby supply, it may get somewhat, the fluctuation of the flow rate will be somewhat less. So that fluctuation, I'm not saying that entirely will contribute to the leakage flow, but in the every supply we can consider, every supply we can compare that key up to this point, whether my flow rate is increased or decreased, or what about my pressure. So when the system pressure will improve, automatically the flow will reduce and the pressure will improve. So that is the analysis, and it's again depend upon the interpretation of the person. And we have understood about the DMA consumption pattern. So based on that, we have did this analysis. It is kind of, see, we are unable to do the MNF, so we have did the MNF like this way. And we have did the step testing used us in a lot way, so like system pressure issues. So what we will do, we will close the steps and we divert all the water in a particular pocket. So automatically this, this pressure of the steps will get improved. Then we started doing the leak reduction. At the same time, obviously, with the drastically reduction of the flow rate, we can identify the leak prone area. As well as, sometimes due to the pressure, maybe the leak may not come out. But whenever we are doing the pressure step test, so we are improving the pressure. So automatically, even the small leaks also may come out. So these are the things continuously we have did where the proper with DMS and we have this did this step testing. Then temporary flow measurement. So at the worst case, if you're I don't know about the DMS and have done the step test, after that also we couldn't identify that. Then what we have did the flow measurement. After the DMA we have installed the temporary flow meters parallelly. Then we have done the water balance between in this pocket how much water is going on. So like that we have made it. So based on that also we have identified the leak prone area or highly consumption area. At the same time, street waste. So suppose particularly some street we have a doubt. So what we will do, we will install the flow meter in the starting point of the street. So before the supply, we taken the consumer meter reading. Then after the supply also we take the consumer reading. Then we will treat the water balance. Then we can analyze the losses what is happened in the particular street. Then pressure mapping, which I have already explained. So pressure mapping is very much important thing. You have to take the pressures and along with your consumer and also as well as you can consider the AZP, CPP or temporary loggers. You can fix that. So that will give a guidelines which is a low pressure area. If it is a very high pressure area, then it will lead you to guide you to do the pressure management over there. Then pressure management. See, pressure in India where IOS work, there was no PRVs and flow control was installed. So most of the areas and all, there's a manual valve in the throttling position over there. So after this conducting the pressure mapping, we have start doing the pressure management by throttling the valve. Then we have observed. Then observe if there is no complaint, then we will keep the valve like that. So this is also the pressure management. Why it is because the pressure is increased means that your leak flow will get increased. So pressure management is important thing, and especially whenever we are doing the improvement work in the DMA. So the pressure management is mandatory because when you replace the pipeline or when you put the when you lay some strengthening pipeline, so what will happen? The system pressure improvement always gets improvement. So that time also we have to do the pressure management. Otherwise, the leak flow in the unidentified leaks will get increased. So that will increase your end of year. Then preparatory work after what are the preparatory works? Preparatory works nothing but for the specifically for the tarmac roads and concrete roads or the pipeline where the deep alignment. So in that area, what we have did after analyzing the principle of the acoustic equipment, we have made a drill of 5 mm in a frequent interval, like 5 meter every 5 meters. Because in India, our pipe size length of the pipe is normally 5 meters. So from the joint, we have calculated. So during the leak detection, what we have did, we just insert the listening stick and we have started listening the leak sound. So this is how we have overcome the difficulties of the high concrete road and the tarmac road. Yes, then leak detection house service pipeline. See, generally leak detection now what we see, okay, it is HC leak, it won't contribute more. But if you calculate the house service connection length, which is greater than the length of your network. So house service connection leaks also the contribute maybe the more water losses. So house service connection leaks, how we can identify? We have identified the use of open sounding method. That is also using acoustic devices. So we have done the house service connection leakage detections. Then gas test. Yes, I have used the gas. I have used NHM, nitrogen hydrogen mixture of the gases. So, but what are the difficulties based? I couldn't succeed in that because in where I was worked, so there's a loose top tap of the consumer inside, and in the network and the walls are not properly. I couldn't close the wall properly. For that, I have to replace the wall and I have to install the new stop tap to the consumer end. So some of the area I have tried, but efficiently I couldn't do that. The nitrogen hydrogen mixture of the gas, and unfortunately I couldn't get a chance to work in a helium gas tracing. Sorry. Then we have done the leak detection in the UGR based on the drop test we have done in all the service UGR. We have done the leak detection using the drop test. Then maintain the leak database in GS platform is very much important thing. So whenever you have identified the leak, so and you have rectified the leak, you have to capture all the data. What type of the leak, whether it's HSC leak, the leak due to crack, or leak due to the joint, and leak due to the high pressure, or due to the burst, and which material you have used, and when it was rectified. So these all the data you have to maintain the GS platform, so that it will lead, help us to do the asset management as well. So if it is a frequently leaking line, then immediately we can replace the line. So this is main thing, it's important. Also, we have did the practical training. So when we involve for the leak detection, what we have did, we have created the artificial leaks along the pipe and kept in our yard. So we asked our engineers to carry out, leak detection using all the equipment. So based on that, we have modulated the pressure also. So how the training we have given, because in the saying in a webinar and the training, it won't give much more to the leak detection. So leak detection literally requires the practical training. So based on the condition, this is what the active leakage control which we have adopted in the intermittent water supply system. That is, one is the increasing flow and flow analysis and ASRB CPT. So these and all monitoring activities. So increasing flow is nothing but so we daily have to monitor your flow and ASRB CPT condition. So once the flow increase, so you can forecast. So up to this month, then so where my NRW will be reached there. So based on that, you can monitor. Then then detect. Then detect. So how we can detect? Once we monitor, we identify the DMA. Okay, this DMA having the problem. So we can go for the step test, and what we did, check the water flow in the manhole or inspection flow. So leak water cannot be stagnant. It will definitely flow. So the water will flow maybe in the manhole or some other utilities. So there is also a phase and some road. And so when you walk in the road, suppose in the pipeline alignment, if you found some dents, that may be due to the leakage. Because of the leakage, there erosion happens, so that's why the road become ten. So that is also possible. Like that, lot of possible ways you can understand how you can. That is depends how you are interpreting that. Then pressure mapping, I have already explained. The network modeling after the calibration, so that is also will guide you to identify the leak point area. Then locate the leak. So after detect the particular area, then you have to again go for the particular location, in which location in that pocket the leak is happening. So we have used the LNC, and we have used the ground microphones and listening stick and packet flow measurement. So flow measurement, nothing but as I said, the water balance, but after the inside the DMA, so that we can understand the what you call the water balance of which packet is contributing more towards the consumption. I mean flow rate. Then confirm the leak. Yeah, we have used listen stick and ground microphone. So after that, it's a repair. So repair with a good quality, but we have always ensured that we recheck the repair area. Then after before backfilling, So once it is it's clearly repaired, then only you can allow for the no what you call it, that backfilling. See what happened. There may not be the big list, maybe the may not be the water may come out like full pressure, but if maybe that's due to some issues, even the droplets also started to leaking, so in the future it may become a it's a big leak. So leak will not start in a day, it start from the since some since before this. So that's why we have to check the leak location after leak. So this is the working principle which I have studied. The book actually published by Iva and other by Mr. Stewart and Bambos. So when I started my leak detection, so this book guided me a lot. So that's why I want to put it over here. So as I have said, acoustic equipments having a lot of issues like PVC pipeline, it won't absorb the things, and the height, the depth of the pipeline, and high density, the concrete and torment. So these are the main issues because of this limitation, because of resonance and sound equipment. So because this is a principle of the acoustic equipment. So what we have learned from this, we cannot change the law of the physics. So at least we can create the situations where we can meet the limitation. So that is what we have did in a possible way. So apparent losses are caused by illegal connection, customer metering inaccuracies, and data handling and billing errors, and underestimation of unmeasured consumption and freebies. So what these are the things we have did to identify the apparent losses. So one is the open sounding, as I think acoustic we have used. So regular frequently send our team to identify that. Then analysis, consumption analysis. So consumption analysis nothing but the data analytics of your consumption data. that is based on the interpreters. You can analysis based on the particular demand of the property, demand of the particular property against which what is their consumption, and you can track their regular consumption, and you can track. So there's a lot of things are there. Then improve the meter reading mechanism. Now when we have work over there, the meter the cycle of the water into supply won't match with the cycle of the meter reading. So we have did some, we have formed the summation, then we have improved, we have changed the software, some software. So some things we have made during the time. Then meter calibration, yes, the meter test bench was installed. Regularly the meter was calibrated, and if there is any damage, meters and all we have replaced. The interpersonal change to avoid the corruption. So we frequently have interpersonal change. The vigilance fix also we implemented. But then capital work, yes, if you are feel in the particular area, there is a lot of illegal connections are there. At the same time, that connections are very old, the GA pipelines, and which is also leaking. So you have, before that you have to do the really ground reality study. So if you replace the houses connection, that will help us to avoid the illegal connection also. And one more thing is that we have to replace the connection, with authorized personnel only. Then install bulk meters. If you feel you have a problematic area, then you can install the bulk meter, and based on the flow and their occupants and their usage, you can again calculate the what is the how much it is contributing to the NRW. So no, in India there's a lot of concerns are there, political interventions, all those things. So during that time, we actually normally install the bulk meters, and we will do like that. So some of the construction tips. So de-linking of existing pipeline to avoid the double line charging, and tube well, which I have already explained how it is affecting the how it is contributing to the water loss. Then hydro testing and leak testing. This hydro testing, generally what will happen what is happening here, hydro testing normally they will do hydro testing the pipe. After that they will install what you call the house service connection. So, but what is I am recommending, so whenever your ULB is going to implement the water loss reduction activities, then hydro testing should do along with the house service connection only. Because the face there is one example, my experience I'm saying. So one we have replaced some pipeline and given the house service connection, then the NRW level is increased than the previous level. Actually it's a 20%. So after that we have analyzed, then we identified the leaks in the maximum, the leaks from the ferrule of the house service connections. So after that we have adopted that okay, so we have to do the hydro testing including the house service connection, so that again the repeatable work cannot be happen. Then replacement of problematic pipes is nothing but the PVC pipe, old leaky pipe, damaged pipe, that will be replaced immediately. Then flow control, installation flow control wall at ferrule. So the figure is showing the flow control wall that you can install, so you can ensure the equal water distribution to the system along the consumer side. Then install consumer meters in the boundary walls of properties for easy access. See, normally what we have observed, someone kept the meter inside their home, someone inside their kitchen. So it is better to keep the meter outside the boundary wall with the proper what you call the protection box, so that it is easy to do the open sounding method also, and we can observe easily the reading of the consumer properties, everything, without disturbing the consumers. Then a passage and warning machine. So if you have possible to lay the pipeline in a separate passages, so and won't allow the other utilities to lay the same area, it is better. At least if not possible, at least the warning measures to be taken care of by using the warning mats and all over things. Then documentation as-built is very much important. Whenever you are replacing the pipeline or doing, so you have to prepare the as-built drawing in a proper way with where the fittings are there, what is the length and depth, and where it's in the right side or left side of the road or center of the road. So everything you have to mention. Yeah, this is some interesting thing. So economic level of leakage and economic level of apparent losses. So the economic level of leakage refers to the point where the cost associated with additional leakage control efforts are equivalent to the cost of producing the same amount of conserved water through those efforts. See here, if you see this line is called the total cost of the water. So initially the total cost is in a higher side, and it is coming down because you are controlling the leak and you are again reselling the water. So one fine moment the cost is again increasing. So this is what they call the economic level of leakage. So that means whatever you save the water, the production cost is greater greater than the whatever the water we have saved. So this is the thing. So it should be the equivalent. So that is what the ELL and ELL actually every ELB has to be checked. At the same time, the ELAL also there's the same concept. So the ULB should calculate the ROI, return of investment, in the long term before initiating any work. It is crucial to invest capital cost strategically based on the amount of water saved and the resulting increase in revenue. So rather than blindly investing in capital expenditure without considering ROI analysis. So we have to consider the ROI analysis. The same thing, it will applicable in the DMA also. See, we have handling around 100 DMAs, but we cannot engage all the people to the in the 100 DMAs. So we have to make the strategical plan. So what we have did, let me illustrate in an example. This is DMA1 and this is DMA2. So here, if you see the losses is 26.6% over here, and here also the losses is 26.6% here. But what is the ml you are going to save here? 1.75 ml and 8.75 ml. So this is the thing. So always, I know you have to invest. Even I have engaged my team in a DMA2 only, so that I can save more water over here instead of this. So this is how the economically we have identified. And again, one more thing. So it is important to note that achieving the targeted non-NRW level in an intermittent water supply system that does not imply that the target has been fully achieved. So it is crucial to consider that increasing the supply levels in a DMA can lead to an increase in NRW level. So if you are achieving the intermittent supply, but if you increase the supply, definitely the NRW will increase. So NRW is not a one-time task. So this is everyone should understand. Wall led by. So these are the interesting cases. Now you see this is the flow graph of the one DM meter of the DMA. So here there's a 12 o'clock the water supply started, and around 3:30 the water supply ended. So after that also you can observe some flow rate over here, like 5 meter cube per hour, here also there. So it is nothing but a wall letting bay. So wall letting may happen due to non-proper closing of the wall. And at the same time, due to the poor maintenance, there is a silt is depositing the groove of the wall. So hence the gate cannot, fix in the wall. So the person unable to close the wall. So what will happen due to the wall letting by, the small, the flow rate is continuously flowing in the DMA at the same time in the negligible pressure. So definitely it won't reach to the consumer end, rather it will reach to the leakage flow. So this thing, if it is an intermittent supply, close the wall properly, just close it. That's the thing. So these type of cases also we have identified. Then we inform the ULBs and we have closed the wall. If the wall is problem, then we have replaced the wall. So after that, we have reduced a lot of water losses due to this wall let by. So another one example I want to share over here. So this you see, this is also in DMA flow rate. The flow is going on, but you can observe the spikes over here. So this is generally 200 meter cube flow is there, right? So if you see the spikes, it is around 1400 cubic meter here, it is 1600 cubic meter here, and I'm saying it is not due to the burst. It is and from the 200 1600 is not at all possible also in practically. So when we analyze the root cause, this is due to the absence of the air wall in the DM location, and sometimes it's due to the operation of the wall, the rough. Some people will open the wall very rough, so the turbulence will happen. So this what created these spikes, and sometimes due to maybe some issues in the meters also. But main thing is the air wall is very much important in the DM location based on the the requirement. So here the second graph depict that totalizer value. So here you can see the positive value, and here you can see the negative value. So negative value is nothing but sometimes EMF meter, surpass this value. So whenever the spike it has been identified, so it will minimize the spike value from the totalizer. So that is why it is showing the negative value here. But it is not a reverse flow. Reverse flow is not at all possible. But it's not at all the time the DM meter will suppress this thing. See, if you see the spikes over here, there is no negative flow. So what will happen? It will account the flow as the water enter into the pipeline. But in practical, the water doesn't enter into the pipeline. So these are the spike cases also we have to monitor, because the spikes are very high, 1600 cubic meter hour, where my actual flow is within 200 meter cube per hour. So if it happened in continuously a month, so it will again the increase in the flow. So the DM is the heart of the DMA. So we have to take care of, we have to monitor the DM meter also. So this is a flow chart is showing about the team composition which I have used. So what are the activities we have carried out? One is water into supply. The team will monitor the analysis of flow and analysis of average zonal pressure, critical pressure point, and analysis of pressure and flow
Vijay?
rate. Yeah. Sorry.
Vijay, I just wanted to let you know we already reached 40 minutes for you to know. Thank you.
Yeah, just give me 5 minutes.
Okay.
Yeah. So water bill and non-revenue water. So unauthorized consumption happened this month. Analysis of metering errors and accounting of operation users, new conditions and disconnections, and meter reading errors. Then asset management, active leakage control, which I have already explained. Then water balance team, then GS updation, then maintenance of the SCADA and related communication instrumentals. Then pressure management, pressure mapping. So this is what the team composition we have used. Then based on the experience, I'm just proposing this NRW reduction activities. So this slide outlines the phased implementation of activities for reducing non-revenue water. The 3 phases include initial NRW assessment, base NRW assessment, and NRW reduction and monitoring. The purpose of this phased approach to enable ULBs to implement NRW activities based on their budget availability and ensuring efficient use of funds. Each phases will serve as a decision making platform and guiding investment to the right areas. So initial NRW assessment having the survey, condition assessment, hydraulic modeling, water audit and energy audit, and estimation and awareness program and change management. So based on this, we can estimate the rate, the investment of the phase 2 and phase 3. Then phase 2, we can set off of all the monitoring system, consumer metering, bulk metering, then DMA formation. So then we will start the base NRW assessment in the DMA wise. So that will give us a target level. So based on the DMA level, DMA NRW level, we will again go for the investment in the replacement of assets, capital works, and leak detection rectification, model calibration, regular NRW assessment, pressure management, and automation software, everything. So this is the phased manner of NRW reduction strategy. Then finally, the paradigm shift. So effective non-revenue water NRW management is vital for sustainable water supply system. So recognizing the need for paradigm shift in NRW reduction. So we here I am presenting a set of guiding principles that can be adopted by ULB seeking to transform their approach. So what are the things actually I am just want to guide in the ULBs that they develop a preventive concept. So you have to take a proactive measures like maintenance. You have to improve the maintenance, leak detection you can do. So it is not like that we have to wait for the entire thing get installed, then we have to start our leak detection. We can start it right now itself, whatever we are having. They ensure the sufficient funding, then reorganize the organized structure and establish the NRW special stocks team, then improve the revenue mechanism. So nowadays, if you observe in India, so flat tariff system is going instead of the consumption based. If somewhere consumption based are there, so the tariff is very much low. So we can go for the telescopic tariff or useless pay less or use more pay heavy. So like that concept we can adopt. Then you have to give the improve the competency of your employees, like practical and task-based trainings. Then mandate the use of the effective indicators. Still now we are assessing our NRW level in a percentage wise, but there is a lot of indicators are there like ILI, Curly. So we have to come into the next level to identify all those things. And ensure the competency of the implementing agency. So we have to ensure the competition of the implementing agency, at the same time the personnel, those who are going to involve in your works, that is also, it's very much important. Then comprehensive contract document, which should be obey with all the standard specifications, as well as it should be tailored to your project requirements. So which is very much is important. Then develop your leak management, your own leak management guideline based on your ULB. Otherwise, you can adopt the guideline from the international, whichever is suitable for you. Then pilot project you can improve. Then in this pilot project you can do all the research and all those things. Then you can make a good thing. Then you can show it to a stakeholder also, so they will also interested to do the NRW management activities. So finally, I'm just ending this webinar with my quote: the success in transforming NRW management requires diligence, continuous practice, and a deep sense of objective. So one should truly feel the water supply network and pave the way towards achieving a lasting success in conserving water and ensuring sustainable water supply system. Thank you so much.
Thank you, Vijay. Thank you. There was a lot of information and in a very limited time, but thank you so much.
Yeah.
So we have some questions. I appreciate it. I think we have to go back to
thank you so much. I can speak in the
recording.
Yeah.
No, good. Well done. Good job. Thank you. So there's a couple of questions. Arnaud, he asked, what is the typical split between apparent losses and physical losses in average to your experience in your systems?
Sorry, come again. What is?
So he wants to know what is in your experience the typical split, the division. I mean the division between apparent and physical losses.
Oh, yeah.
In your
So
system.
in my knowledge, yeah. So if I say, give you an example, suppose 100 liter I have saved, in that 100 liter, around 50 to 60% due to the replacement of the old age pipeline. Then 30 to 50%, 30 to 40% due to the leakage, the physical losses. Then 10, maybe 10%, 10 to 5% due to the illegal connections. And the illegal
So
connection,
you're saying that the apparent losses is higher than the physical losses. That's what you're saying.
No. Physical losses is more than the apparent losses.
Oh, okay. All right. Then Danesh is asking how pressure management is being done.
Yeah.
You understand how you implement pressure management?
Yeah, pressure management. Before doing the pressure management, you have to do the pressure mapping. So pressure mapping in the consumer tab, you have to take consumer pressure at the consumer end. So what we have did, we have used the calibrated pressure gauge with some hose pipe. Then in every street, initial stage and middle and end of the street, the both houses, we have taken the pressure reading from the pressure mapping. So if I came to know that, okay, now after that, you will see the low pressure area and high pressure area. So if it is a high pressure area, so and as per design and your calibration network, you don't need to that much pressure need to provide to that area. So what you will do, you have to throttle the valve 1 or 2 rounds, and you have to wait. You cannot throttle the valve immediately, to reduce the pressure. You have to wait 2 or 3, 4 supplies. So if you observe there is no complaint from the particular packet, then again you have to reduce, because we don't. I'm talking about we don't have any PRE valves. I'm talking about the manual valve which we have done, the pressure management using the manual valves. Hope I answered your question.
Okay.
I actually, my face is very fast. If anyone is not understand, please call and you can send me the mail also, so I can explain.
Yeah, I think everyone can see your email address on the screen now, and they have more questions. They can directly write to you. Okay, there's another question. So Jeff is asking. He's interested to know in the digitalization of your networks. So your surveys and your GIS and GPS digitalization. If you can tell more about it. If you can explain a little bit more on how was your experience, I suppose, on digitalization of the networks.
Digitization, yeah. So the water loss detection, we have used only the WebGIS. So WebGIS and SCADA, we have connected with the WebGIS, and rest all the analysis we have made it by in-house, right? With the use of the Excel and all those things. And apart from that, the digitization, if you are talking about the automation of the entire network, so in India, I think it is some area it is still in process, but I didn't get opportunity to work with the entire digitization. But in my view, if you want to do the digitization, then we can go for the phase wise, which I have already explained. So once we are, before that, we have to clear the entire network. And second thing, if you directly go to the digitization, every digitization requires the database. And most of the ULBs they don't have the database. So first we have to develop the database. And second thing, if in Indian culture, you cannot predict the date when the demand will increase. Like for example, Diwali, the function festival will come or one time in this year, and the same festival maybe you can observe in the next year. So again, it required the deep knowledge about the particular area, and even the festival also will vary. The state to state. We have a 28 states over here, so that is also one thing. And second thing, to do the digitization, we have to install a lot of sensors over there. Then only we can understand. We can do that, because even in the DMA, if you form the DMA also, we have what we have faced here. So if, for example, the DMA, it is having the 4-hour supply over there, but the entire 4-hour supply, the properties in the DMA won't receive the entire 4-hour supply. So initially the person will give a supply to the particular packet, then the person will give another packet like that. So this is also another reason. So before digitization, we have to improve the network, So a lot of work has to be done. Then we can go for the digitization. Yes, in my point of view, we can do the digitization from the raw water intake well to service at present. Further, we can go by the DMAIs. So this is what my understanding based on the Indian scenario.
Okay, thank you for that. So there's another question asking when is this webinar it's going to be uploaded? It's going to be uploaded soon, and Ian shared the link to all the webinars. So it's going to be in the same link. Okay. Vijay, I have one question for you. You said that you in your systems you tried, in order to do leak detection, you tried to simulate continuous water supply. So you pressurize your systems for a number of hours, days. I'm wondering how long it took you to get your systems stable before you start doing minimum night flow analysis and leak detection.
Yeah, I couldn't get the minimal night flow analysis because I couldn't get the opportunity to that. There is only one DMA where I was worked, so they're having the 24/7 supplies that we have did that. So this optimization, I'm telling, if it is a 5-hour supply, we have get the system optimization maybe after 7 hours, because where I was worked, so there the people are using the sump. So no, after the supply hours, maybe if you give the 2 or 3 hours, the sump will get filled. So after that, it will automatically get saturation level. So another 2 or 3 hours we have actually, I know, given the water supply to make the saturation to the particular network. So after that, we have closed the step walls. So before we doing all those things, what we have did, we have analyzed the leak prone area based on flow measurement or analysis, or by opening the manholes. And in India, if you come there, if you open all the manholes, definitely the fresh water flowing during the supply time, we can understand that. So based on the analysis, then particularly we have divert the network in the particular area. So based, so what will take, as I said, I think 3 hours it will take after the supply, after the supply hours. You have to increase the supply hours. Hope I can answer your question.
Okay, thank you. I'm gonna unmute, and if anyone wants to have another question, please go for it. Unmute yourself if you have another question. If there's no more questions, then I will just thank you, Vijay, very, very much. That was a very interesting presentation, webinar. Thanks everyone for being here. Thanks for attending the webinar. As I said, this is going to be loaded to the YouTube page soon by Gary or Stuart, and then you're going to have access to it. And please feel free to contact Vijay if you have any other question. Then I will just conclude and close this webinar. Thank you again, Vijay, and thanks everyone for being here.
Thank you.
Thank you so much. Bye, everyone.